important problem of Riemann integration. And problem is, a function f is defined on 0, 1 by fx, this is equal to x square plus x cube, for x is rational and x plus x square, x is irrational, right? And the first problem is evaluate integration 0 lower bar to 1 fx dx, that is the lower integration, and 0 to 1 upper bar fx dx, that is the upper integration. Okay, and show that f is not integrable, that is not Riemann integrable. So from the second problem it is obvious that the lower integration and upper integration must not be equal. We have to find the lower integration and upper integration of this problem. We first let I, this is equal to 0, 1, okay, because we cannot write 0, 1 repeatedly. We write for this interval as I, and x is rational means we can also write x belongs to I intersection q, where q is the set of rational number, and x is irrational, that is we can also write x belongs to I minus q, right? This is I intersection q and this is I minus q, because I intersection q means the rational number in 0, 1 and I minus q is irrational number in 0, 1. Here it is given in language, this is rational, this is irrational. Now the second point is, we know that if x belongs to I, that is 0, 1, for all x belongs to I, we know that x greater than x square, right, and x square greater than x cube, because if we increase the integral power of x in 0, 1, then the total term, that is the term of or value of x to the power 3, x to the power 4, x to the power 4, x to the power 5 continually decreases, right? So we adding these two results, we get x plus x square greater than x square plus x cube for all x belongs to I. Okay, this is very important relation for this problem. Okay, now we first make a partition of this interval I. Okay, and let the partition of I is Pm, this is equal to 0, 1 by n, 2 by n, 3 by n, r minus 1 by n, r by n to n by n, because this is 1 and this is 0 by n means 0, and we name this partition as Pm. Clearly the length of each subinterval, here Rx subinterval is r minus 1 by n, r by n, and we name this is xr minus 1 xr, and the length of the Rx subinterval is delta xr, this is xr minus 1, so this is r by n minus r minus 1 by n, this is 1 by n, and length of every subinterval is 1 by n, clearly, and this is tends to obviously 0 as n tends to infinity, right? Now another more point we use here, if we take the function fx, this is equal to x square plus x cube, okay, the first part, then we get f dash x, this is equal to 2x plus 3x square, and this is greater equal to 0 for all x belongs to y. Clear? Similarly, if we take fx, this is equal to the second portion x plus x square, and the derivative is f dash x, this is equal to 1 plus 2x, this is obviously greater equal to 0 for all x belongs to I. Okay, so we say that this function or the given function fx is monotonically increasing. Okay, monotonically increasing because for both the case f dash x greater equal to 0 for all x belongs to I. So this is monotonically increasing function. And for monotonically increasing function, this type, the rough sketch of monotonically increasing function is this type. And if we make a partition of this interval AB, then we get the partition of type this. Okay, and we let this is xr minus 1 and this is xr. Clearly this is the infimum and this is the supremum. So we say from this property, the infimum of any interval or any subinterval occurs in the lower point or the left hand point of the subinterval, and supremum clearly occur in the right hand subinterval. Okay, that is in the rth subinterval, infimum occur at xr minus 1 and supremum occur at xr, because fx is monotonically increasing function. Okay, this point is very important for this solution. Now we let capital MR be the supremum of f of x and small mr be the infimum of f of x in the rth subinterval. Okay, we rth subinterval, we name this rth subinterval as IR. So we write here this is IR and this is also x belongs to IR. We have to find two values, that is capital MR and small m. Okay, and from the property of monotonic increasing, it is clear that the supremum value, that is the value of MR, occurs at the right hand point. Okay, that is at xr, and the infimum value occurs at the left hand point. But there be a difficulty, and we look carefully this question. We find MR. This is if the right hand point xr is rational. Okay, there is no problem. Then we put xr, this is equal to r by n, because this is xr. This is from the partition, and the value is supremum of fx as x belongs to IR intersection Q, that is the rational point in IR, and this is fx. So this is given by supremum means this value, and this value is not for the rational point. This is for the irrational point and this is for the rational point. And so we first write xr square plus xr cube. Okay, this is the supremum if xr is rational, right? But we know that this is greater than, this is less than xr plus xr square for all xr belongs to IR. This xr may be rational or may be irrational, because this relation holds for all x belongs to I. Okay, that is for all x belongs to IR also. Value of capital MR, that is supremum of fx when x belongs to IR minus q, right? Here xr, this is r by n does not belongs to ir minus q. So how can find the value of mr in this case? Then we consider, we write here we consider un a sequence of irrational such that limit n tends to infinity un, this is equal to xr. Okay, because we know that for any rational number there are infinitely many irrational number in their neighborhood. So we can make a sequence of irrational around any number of, or any irrational number, or sorry, any rational number, right? Here xr is rational and the sequential points are irrational. This is our even, and in this case this supremum can be written as limit n tends to infinity un, where un is the sequence of irrational number. And what is the value of limit n tends to infinity un? This is the second part. So this is un plus un square, and there will be limit n tends to infinity. And putting the value of this limit, we get xr plus xr square. Okay, so from both the case we get mr, this is equal to xr plus xr square. So this is xr means r square by n square plus, sorry, r by n plus r square by n square, and this is the supremum of fx in the rth subinterval, right? And now we go for the infimum mr for the rth subinterval. For the case of infimum, we first find infimum x belongs to ir intersection q, and this is fx. So this must be attained at the left hand endpoint. Okay, that is at the point xr minus 1. Here we write this is xr minus 1, this is r minus 1 by n. Okay, if xr, this is not xr, this is xr minus 1, this is r minus 1 by n, and this is xr minus 1 belongs to ir. Okay, so here x, for all x belongs to ir intersection q, this is f of xr, and the value of this mr is given by, this is x r minus 1 square plus xr minus 1 cube, because this is the rational point and we know that this is the lower than this. Okay, and this is the value of mr in the rth subinterval if xr minus 1 is rational point. Clear? Now for the second case, if xr minus 1 is not rational point, here xr minus 1, this is r minus 1 by n, this is does not belongs to ir minus q, that is this point, or that is infimum x belongs to ir minus q fx. What is the procedure? As in case for the supremum, we also consider a sequence un, sequence of irrational number such that limit n tends to infinity un, this is equal to xr minus 1, right? And in this case limit n tends to infinity f of un, and we know that this is limit n tends to infinity f of un, this means un plus un square un plus un square, and putting the value of the limit n tends to infinity un, this is equal to xr minus 1, we get the first limit is xr minus 1 and the second is xr minus 1 square. And we know that this value x plus x square greater than x square plus x square for all x belongs to I. That is for every rational and irrational. So we can write here this is xr minus 1 square plus xr minus 1 cube. Okay, and from these two cases we can write small mr. This is small mr. We write here small mr. Sorry, this is small mr. This is equal to xr minus 1 square plus xr minus 1 cube, and this is given by r minus 1 square by n square plus r minus 1 cube by n cube. This is the infimum and this is the supremum. Okay, these two are the main factor of this integration. Now we have to find the upper sum and lower sum. Then taking limit n tends to infinity, and we get upper integration and lower integration. The upper sum for this problem is upper sum is UPNF. This is equal to summation r equal to 1 to n. MR, this is the supremum, and xr minus 1. This is the interval length or subinterval length. We already calculate the subinterval length here. This is 1 by n. So we put the value of subinterval length. This is 1 by n, and also we put the value of mr. This is also we get r by n plus r square by n square. Okay, and the range of r is 1 to n because we get the upper sum at the right end point. So this is n equal to 1, n equal to 2, n equal to 3 to n equal to n. Right? Now we get for the first term 1 by n square into summation r, and for the second term 1 by n cube into summation r square. This is 1 to n, this is also 1 to n. And this is 1 by n square into 1 plus 2 plus 2n, and for the second term n cube into 1 square plus 2 square to n square. So by using the formula 1 by n square, and this is n into n plus 1 by 2, and 1 by n cube, this is n into n plus 1 into 2n plus 1 by 6. So this is half into 1 by, this is 1, n cancel out, 1 plus 1 by n, and the second term is 1 by 6 into n cancel out also, 1 plus 1 by n, 2 plus 1 by n. Now the upper integration 0 to 1 upper bar, fx or f. This is upper integration, and this is given by limit n tends to infinity u pn f, right? And this is limit n tends to infinity u pn f, means this term. If we take n tends to infinity, then from here we get this is half and this is 1 by 6 into 2. So we write the value is half into 1 plus 0 plus 1 by 6 into 1 plus 0 plus into 2 plus 0, and this is given by half plus 2 by 6. So this is half plus 1/3, this is 5 by 6, and the value of the upper integration is 5 by 6. We write here this is equal to 5 by 6. This is the first answer. Okay, now we find lower sum. This is LPNF, and this is given by summation r equal to 0 to n minus 1, because the lower sum means infimum and infimum occurs at the left end point. So this is 0, 1, 2, n minus 1, right? And we write here mr into xr minus 1, and we put the value of mr and the interval length. Obviously the interval length is 1 by n, and small mr is given by r minus 1 whole square by n square plus r minus 1 whole cube by n cube. Okay, and we get two summation. The first summation is 1 by n cube into summation r minus 1 whole square, and this is given by r equal to 0 to n minus 1. And the second summation is 1 by n to the power 4, and the summation is r equal to 0 to n minus 1 r minus 1 whole cube. And expanding this summation, we get 1 by n cube, and this is the formula like this, and this is given by here in place of n we get n minus 1, and this is given by n minus 1 plus 1 into 2 into n minus 1 plus 1 by 6. This is the first term, and the second term is 1 by n to the power 4, and this is n minus 1 into n minus 1 plus 1 by 2 whole square, and so we get 1 by n cube into this is n into n minus 1 into 2n minus 1 by 6, and the second term is 1 by n to the power 4 into n square into n minus 1 whole square by 4. Clear? And here we cancel out n and get the value as 1 minus 1 by n, the first term, and the second term is 2 minus 1 by n into 1 by 6, and the last term is n square cancel out, and this is 1 by 4 into 1 minus 1 by n whole square. Now we get the lower integration, that is integration 0 to 1, 0 lower bar to 1 fx dx. This is equal to limit n tends to infinity, and this is lower sum LPN f. Clearly, from this term we get by taking limit as n tends to infinity. The first term is 2 by 6 because here 2 and this is 6, and the second term is 1 by 4. Okay, and this is 1/3 plus 1/4, so this is 12, this is 7, and this is the value of lower integration. So the value of the lower integration is 7 by 12. Okay, 7 by 12. And for the second problem, it is clear that since integration 0 lower bar to 1 f, this is not equal to 0 upper bar to f, so this function is not integrable because lower integral and upper integral not equal. Okay, and this is very important problem of Riemann integration. Thank you for watching.